We're now going to walk you through the process of core validation. The purpose of core validation is to take our calibration that took us from dielectric to actual air void content and ensure that what we're actually measuring in the pavement reflects the air void content of the placed pavement. So the ideal scenario for our RDM cart is to be able to use cores that are already going to be taken as part of the normal quality assurance process. So in this case, our core location that was randomly selected for the purposes of this illustration was located at 655 plus 06.5. So typically, this will be marked with a survey wheel so that you make sure you're at the correct stationing location, and this offset was at a negative 4.5 feet. So once this location is marked and this was identified as a spot that's going to be part of our random core location, we need to input the correct information into our RDM cart once we have the sensor centered over that core location. So the first thing you'll want to do is make sure that your center sensor is centered over the top of that core location. And now's the time I like to mention that the next version of this RDM 2.0, will be much more convenient for these types of cases because the laser should be centered right on that paint dot for the new system. For this one, you have to kind of eyeball it based on making sure that the center of the sensor is lined up with that paint dot. So now that we're relatively centered, we'll start to walk you through the inputs in the file information to indicate that it's a core validation location. Now that we're centered over our core location, we can input our correct station location where the sensor is. This specific core was located at 655 plus 6.5. So we're going to put 6.5 after our 655 station indication. We're facing in the increasing station direction, so we keep that unchecked. And our offset of our core is at 4.5 feet from the joint. Since we're facing up station and it's left of our reference line, we're going to put a negative 4.5 in this location. Next, we're going to want to change our file name. In this case, we're going to put dash 114. That tells us that it's sensor number 114 that's measuring over the top of the core, dash 89.1. 89.1 is the core ID number for this specific core. Of course, for you, you should be putting in your specific sensor ID as well as your specific core ID in these spots. We're going to press accept, and we're going to press collect data. Now this brings us to the same screen that we were in for validation and routine testing collection, but now we're actually going to use collect time because we're just centered right over the top of that core location. So once you press collect time, it's actually going to begin collecting data right away. And you're going to want to watch up here at your time collected indicator there and make sure that you're collecting data for anywhere between 10 to 20 seconds to make sure you get a good average of what the reading is at that specific location. So once we press stop and save, we like to collect 2 readings just to validate that what you're doing is repeatable and you're getting the same answer. So we go again back down to collect time, and you'll see it's starting to count up, and you also have your collect file name that will give you 2 separate indications of your data collection. Now, once we press stop and save, we can go to playback last and see that our dielectric in this location for sensor 114 is approximately 3.32. And in this case, we'll be able to compare that to what we get when the core is actually taken from the pavement.